sound runs this way. It doesn't come down. It's within the building, and it sits on the building, on the floor. So there'd be a whole series of these in a circle, okay, and they could be all rung and so forth. So I showed this about 2 years ago at a conference, and this one Waldorf teacher came up to me and says, I'd sure like to try to make that bell. So I said, well, sure, okay. A lot of people have asked me, yeah, I'd like to make that. And they don't ever do it. But this one guy, he kept at it. And so I said, okay, I'll give you drawings. See what you think. And I never gave any drawings before. I have perfect drawings of this. It shows the inside, what the sound what would happen inside. So anyway, the guy's really serious. And his name is Tim Allen. He's a Waldorf teacher in Petaluma. And he saw this lecture, and he said, I'm going to make it. And sure enough, he did. So he brought it here. You can see the bell, and you can hear it. So Tim, Tim, where are you, Alan? Tim Allen, come on up here. He got a grant to pay for the bronze. It's expensive. It's 40 pounds of bronze, and he had to figure out how to make everything. So I'll let him talk for a while.
All right. So I heard Frank give this lecture, like he said, and he showed this bell. He had his whole setup, and then he put it back down. And after the lecture, I said, "Can I ring your bell?" And that's when he told me it was wax. So let's see. I have my drawings. Let me get my drawings, Frank. So I have still these drawings that Frank gave me a couple of years ago. So this is the drawing he gave me as a cross section for the bell. And so I took this drawing and I made blades out of aluminum that were exactly this. There were 3 of them. 1, 2 from the outside, and then 3 had to come in at a diagonal. And then I turned it on a lathe in wax. And can everyone see it? So it does weigh 45 pounds. It has this shape inside. It has a cone inside. Underneath. And then it has that to stand on.
What? Yeah, I think we can. Tim, you want to put it up on the table?
Sure. What I can base my expectations on, something like this. And then I got something this size. And I have some experience building instruments, and I've always gone from the acoustical function to the form, and this was going from Frank's form and then finding out what happened acoustically. So I was expecting, I wasn't sure.
Yeah, Tim, what do you think this is going to sound like?
Right.
I think it's going to sound low.
Okay, there's one idea. It's important to think about these things because all of this and everything you've seen so far is all based on thinking.
I wouldn't think it would resonate very long. It would be a shorter period of sound.
A shorter sound.
Yeah, instead of extending out for many, many seconds, it would just be more tunk, tunk, yeah.
Yeah.
More of a staccato.
Yeah, especially if you ring that bell, it's like boom, 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 boom.
I think it's going to have more than 1 octave.
More what?
More than 1 octave.
What do you think, Tim? What they're saying, huh? They're in for a surprise, aren't they?
Here we go.
Stand back.
Now I also want to ring it louder, but it's pretty sharp, so you're welcome to plug your ears if it's painful. But yeah, listen to where the sound comes from as I start playing it louder.
It's loud.
It sucks in. I don't know, to me it feels it doesn't ring out, it comes in. Like it's coming from the periphery to the center rather than from the center to the periphery. I don't know. That's my experience.
I feel like the sound comes out sort of this way, and then another sound comes out of that sound.
Yeah, there's some sort of harmonic convergence going on.
Mm.
but I'm not sure the term.
Conversation.
So, acoustically, I compared it roughly to a wine glass. It's mounted in the center. The top rim is free. It's pointing up. And again, I had some expectations that it would function similarly. So that if you hit a wine glass, the basic vibration is you have this circle, and the impact compresses it so it turns into an oval, and then it expands again, and it would be like if it's like that silent, then and you hit it this way, then it oscillates between that type of shape and that type of shape. And that creates the primary or the fundamental tone with something like this. Can I have some water? Oops. So with water in it, it still rings because the primary movement is up at the rim here. And it will ring. The pitch changes, but it still has resonance, right? So how much water fits in this bell is 5 cups. So if I go 1/5, 1 cup. Frank, will you pour? Will you pour the water in?
Sure.
Just pour a little bit and then a little bit more. It doesn't change the pitch, but it pretty much kills the resonance. So the water's sitting down just in this little, it's leaking out too. It's sitting down in this little trough where the cone meets the outside shape of the bell. So, I don't really know what that means, but I'm still trying to figure it out. There's a significant amount of movement happening down here. If the water, there's about an inch of water down here. If the water there can dampen the whole resonance, then something's happening here that doesn't happen in the shape of the wine glass, for example.
But that one doesn't have a cone in it.
It doesn't have the cone in it yet. But this was just as close as I could get without building a series of models.
It's great.
Thanks.
Thank you.
He's always told me, he says it's a mystery bell.
Doesn't work like it should.
But this is an earth bell. It's called a geo bell. That's a spiral bell. And the thing is that it is a mystery, and Tim is working on that. I have no idea that was going to do that. I just knew how to transform a form and turn it inside out, okay? I had no idea what it would sound like or whatever, but there's not a bell like it anywhere. I looked through the bell history and the books and history and so forth, nothing like it. So it is, if you think about it, the tone of this big bell on this one, it's reversing the sound also. It's also reversing its direction, not downward, but upward. So these are the things that I think are the indication of where we have to go with architecture. I think that we have to go in this direction. Here's Tim. See? Was a nice guy, right? Now I'm going to come to this part here. I wanted to show you something that was lawful, because a lot of people, well, what's he mean by lawful? It has to be lawful. Okay? It's not fantasy. So one of the things I was told, I went to the Goetheanum and presented my work there, and they filmed it. And the head of the mathematical section told me, he says, you know, if you could find the dual of this form, he said, it would definitely help the heart. And of course, this form is the left ventricle of the human heart, which is on the first lecture. It is the geometry behind the human heart and the left ventricle, which receives the red blood from the lungs, which is the blood that's been etherized. It's the blood that's pure. Okay, and then it receives into this bell-shaped form. And so he said, if I could find the dual, it would help the heart. Okay, so here's the examples of a dual. So this is one of the Platonic forms. And that will fit into the cube. And it's called a reversal because it goes from points to faces. Okay? So the cube, when it's centered around this, has a healing effect on this form. It has a healing effect. This is the form that is said that goes around this form at night. But during the day, it's gone, and this now been revitalized. It's become reconstructed and renewed for the next day. And this is called a dual because this will go inside, and also I can take this cube and put one of these on the outside. That's why it's called a dual. So let's see what I have on here. I have, here's one on the outside. So I've taken the cube and put it into one of these. So that's what's known as a dual. Now, here they are together. Inside the cube and the cube inside. It explains kind of what a dual is, because a dual is hard to explain. Because it's the logical movement, mathematically, of reversing. This is inside, now it's on the outside.
Inside the heart, you mean?
No, it's inside the form. In other words, we're just looking at form right now. Don't think of the heart. Just look at the form. I'll get to the heart. So that's kind of what I wanted to explain what a dual is. So I went home after that comment. I went home and tried to figure out what the dual would be, and he said that it probably would be 14-sided, because this form is 7-sided, and so it's probably a 14. Well, one thing about this is an asymmetrical form, yeah. So just because it has 7 sides and 7 points doesn't mean it's going to be 14. So it didn't sound quite right to me, but it was better than what I thought before. So what I did was I went through a logical form transformation process that's all based on science. It's not speculative. It's starts out with the 7. I'm going to put these here. Kind of come over. Here's the 7. That's the 7-sided form. That are originally, okay. Put a bubble in here. It turns into the left ventricle. Okay, so what I started to do was to cut the edges off.